Imaginary and complex numbers. So what is an imaginary number? What is a complex number? Let's first start out with what is a real number. A real number is any number you could possibly think of, right? 3 is a real number. Negative 27 is a real number. 1/2 is a real number. I mean, even if you did like something like the square root of 7, which is not a nice number, if you did it with a calculator, you'd get something like 2.645751311, and it keeps going. That's what we call an irrational number, but it's still a real number, okay? So what are we talking about when we say something that's not real? When you look at a number, and specifically the square root of a negative number, that right there is actually an imaginary number. The square root of negative 9 is 3i, okay? You can't take the square root of a negative number. And what we're going to learn today is that an imaginary number, where does an imaginary number come from? It comes from the square root of negative 1. The square root of negative 1 equals I. That's a fact that we need to know. So yeah, those are imaginary numbers. When you take the square root of a negative number, it's not a real number. It's an imaginary number. Now, where does that all come from? It comes from, give me a second. Man, that's ugly. There we go. Where does it all come from? Well, what is the square root of 9? It's 3. And why is the square root of 9 3? Well, that's because 3 squared gives you 9. When I say what's the square root of 9, what I'm really saying is what number squared will give you 9. All right? So again, if I say what's the square root of 36, I'm really saying what number squared will give me 36, so we know the answer is 6. Now, but if you say what is the square root of negative 4, you can't think what number squared gives me negative 4 because there is no such number. If you say 2 squared, it does not give you the negative 4. If you say negative 2 squared, it still does not give you a negative 4. It's impossible to take a number, square it, and for it to give you a negative, right? So that's where the rule that we learned just now, that the square root of negative 1 is really just I. We need to know that. So whenever we do see a negative inside the root, we could simply rewrite it with the I on the outside and no more negative on the inside. And now you could look at it and say, okay, what is the square root of 4? Oh, that's 2. And the I is like a variable, like any other variable, kind of like x. And you would just say, what is I times 2? Oh, that's 2i. And that's why when I ask you what's the square root of negative 4, the answer is 2i. Now let's mess with I for a little bit. Once again, where does I come from? It comes from the square root of negative 1. The square root of negative 1 equals I, and you could also say that I equals the square root of negative 1. Forward or backwards, however you say it, it's fine. So, anyway, if we know that I equals the square root of negative 1, then we should also be able to come to a conclusion if I take I and square it, okay? The I squared actually is negative 1, okay? And you're thinking, what? How's that possible? Well, let's think about this. If we know for a fact that I equals the square root of negative 1, and down here we have I squared, what is I squared really? I squared is really an I times another I, okay? But we just said that I was the square root of negative 1, so I want to take the square root of negative 1 and replace it with this I. I want to take the square root of negative 1 and replace it with this I. So I should have the square root of negative 1 times the square root of negative 1. And we all know that when we take a radical value and multiply it with itself, your answer is just the number within the radical. So when you take a radical, multiply it with itself, the radical disappears. So that is why I squared equals negative 1, okay? And we could even mess with it further. We could say, what is I to the third then, right? Or what is I to the fourth or I to the fifth? Let's take a look at I to the third. Well, I to the third is really an I squared times another I. So I already know that I squared equals -1, so I really just have a -1 right here times I, which is simply a -1I, or a negative I. So I to the third could also equal -I. Pretty interesting, huh? We could get even crazier and go like I to the fourth, I to the fifth. We go to I to the 16th, right? Whatever it is, we could figure it out. But let's not spend too much time. Let's just do one more. Let's go with the I to the 7th. Why not? I to the 7th. How would we tackle this problem? I to the 7th power. Well, we know that I to the 2nd is a -1. So let's rewrite this with exponents. And let's say I squared times I squared times I squared times I. That'll give me the I to the 7th that I have up here, right? So we really have a -1 times a -1 times a -1 times an I. So it's really easy to find your answer here using the I squares. And the I squares will end up giving you -1 times -1 is +1. So you really just have a -1 times I. So I to the 7th is really just -I. Pretty cool, huh? I know, you love it. Anyways, let's move on to something cooler. Let's solve -2x squared minus 4 equals 22. Okay, so notice that there's only one x squared right here. There's no x here, there's no x over here. So whenever you just have an x squared, you don't really have to factor, split, and solve, or you don't have to do anything that we used to do before. Since there's only one x squared, let's isolate it, and then we could get rid of the square by square rooting both sides. This is an equation we are solving, so let's actually get to it. Plus 4, we're going to have 2x, or -2x squared equals 26, and divide by -2, divide by -2, you're going to have x squared equals -13. And last but not least, let's get rid of the square by square rooting and square rooting. Now remember, we did apply a square root on both sides, and whenever you apply a square root on both sides, you're going to have to put a plus minus right in front of your answer. Okay, so we have a plus minus in front of the square root of -13. Another important detail is you have a negative in here. You can't have a negative in there. Remember, that just means that it's an imaginary answer. So we're going to put an I out in front, and then the square root of 13 inside the root. And ladies and gentlemen, we are done. That's your answer for that quadratic equation. X equals plus or minus I squared of 13. Let's take a look at another one. And I'm not just going to ask you to solve. I'm going to ask you to find the zeros. So let's find the zeros of this function. F of x equals x squared plus 6x plus 14. By the way, these questions are coming from the handout that I gave you in class today. So finding the zeros, what are the zeros? They are the x-intercepts. They are the answers. They're the solutions. If you want to think about x-intercepts, how do you find the x-intercept? You have to set y, which is really f of x, set it equal to 0 and solve. So if you could factor, split, and solve, then you'd be able to find the intercepts, which means that you'd be able to find the zeros. So if I tried factoring, thinking what times what is 14, that if I add together is 6, that's not going to work because 7 times 2 is 14. If you add it together, it's 9. It's not 6. So we can't just factor, split, and solve, but we could complete the square, right? We could check that out. We could complete the square. And if we complete the square, we simply move the 14 a little to the side. Remember, we're not solving an equation here. This is f of x, so I don't want to move it to the other side. I want to keep f of x by itself. Now I'm going to complete the square by taking half of b and then squaring it. Okay, half of b is 3. Square it, you get 9. So I'm going to add 9 right here. Now I can't just magically add 9 to this side of the equation. I either add it to this side also, or I subtract 9 also to this side to keep it balanced. So I'm also going to subtract 9 right here. Okay, now again, completing the square, what's the purpose of it? To get a binomial squared. And the binomial squared right here will be x and then half of b, which is 3, and there's a plus sign right there between it. And when we take a look at the 14 minus 9, we get a positive or a plus 5 down here. Once again, this is still f of x, and now it's in vertex form. Does that help us? Well, kind of, because if we think about the vertex, it's going to be negative 3, positive 5. This thing's opening up because the a value is 1, which means that this is not going to have real intercepts. It's not going to have real x-intercepts. It doesn't cross the x-axis. So when you're trying to find the zeros, you're not going to find real answers. They're going to be imaginary answers. So what could we do now? Let's find the x-intercepts algebraically by setting y, which is this one, set it equal to 0, make that a big giant 0. So I'll have x plus 3 squared plus 5. But you know what? Instead of putting the equals 0 on this side, I want to put equals 0 on this side, okay? Just to be a little more comfortable. I like having the equals 0 on the right side. And now let me solve this thing. I'm going to subtract 5, and I will have x plus 3 squared equals negative 5. And now to get rid of the square on the x plus 3, we need to square root both sides. Sorry about that. Anyways, we're going to square root both sides. And remember, you're applying a square root. So you're going to have a x plus 3. And when you apply a square root within an equation, you're going to have a plus minus in front of your answer, always. And remember, there is a negative, a square root of a negative, which means that you're going to have an I out in front of your root of 5, the square root of 5. Anyhow, there's only one more step to do. That would be to move the 3 over to the other side. There we go. Made it a little smaller to have more space. I'm going to move the 3 over to the other side. Subtract 3, subtract 3. Your answer will be x equals negative 3 plus or minus I square root of 5. Those are your zeros. Those are your intercept values, which means that they're not real because it has an imaginary in there. And that's how to find the zeros of that quadratic function. That even if you were to graph it, it doesn't cross the x-axis. So there are no real x-intercepts, which means that there are no real zeros. They're imaginary. There are still a couple other things to discuss when it comes to imaginary numbers. One thing would be to, this is when you're solving. We just did solving right here. All this is solving. But let's say you were simplifying an expression that had I in it. Just like radicals can't be in the denominator, you don't want to leave an imaginary in the denominator. Let's say you had 2 over 3i. You don't want to leave it 2 over 3i. What you want to do is multiply both top and bottom by I. Okay, that way you'll get a 2i on top, which is totally fine. And down here, we know that I times I is I squared. So you really have 3 times I squared, which is really negative 1. So you get a negative 3 down here. So your final answer, the best answer you could give here, is a negative 2i over 3. Notice that I moved the negative that's on the denominator right here in the middle, or you could also put it on top, but don't leave it at the bottom. It doesn't look as nice. So that's your final answer there. I almost forgot to mention a very important thing, what a complex number is. We already know that the square root of negative 1 is I, which makes it imaginary, but what's a complex? A complex number has 2 parts. It has a real part and an imaginary part, okay? It's pretty much a binomial that has a real part and an imaginary part. An example would be 3, that's the real part, minus 2i, that's an imaginary part. This is what we call a complex number. So it has an imaginary within it. It's a binomial that has an imaginary, it has a real number, and that is what we call a complex number. We will continue with this on the second video.